All right, we are about to go on what might be the ultimate adventure, a trip to the nearest black hole. It's got to be one of the most dangerous and most awe-inspiring journeys you can possibly imagine. And you're coming with me, so go ahead and strap in. This is one of those questions that has always fascinated me. I mean, we see them in movies all the time, right? But what would it really feel like to travel across the cosmos and come face to face with one of these things? So let's see if we can find out together. Okay, so this is our ride, the Invincible. She is an absolute marvel of engineering, built for exactly this kind of impossible trip. And of course, I'm not doing this alone. This is Liam, my AI companion. His job is to keep the ship running and hopefully help us make sense of the totally mind-bending physics we are about to run into. So why do we need a ship as advanced as the Invincible? Well, this number right here, this pretty much explains it all. 77,000 years. That's how long it would take our fastest probe, Voyager 1, just to get to the nearest star. I mean, the sheer scale of space, it's almost impossible to wrap your head around. And we're off. You can feel the engines roaring as Earth just falls away behind us at a breathtaking speed. And just like that, in what feels like mere seconds, we're 200 miles up, watching entire continents drift by. But up ahead, yeah, there's our first landmark. Okay, look at that. It's the International Space Station. And these numbers, wow, they really put its size into perspective. At over 350 feet, it's longer than a football field. And that price tag? $100 billion. To put that in perspective, you could buy 250 Boeing 747s for that kind of money. It is the most expensive single object ever built. All right, we're climbing even higher now, about 1,300 miles up, and we're entering the realm of satellites. The sense of scale out here is it's mind-boggling. So get this, the lowest orbits, that's like stacking the Grand Canyon on top of itself 4.5 times. The highest ones, their path is nearly as long as the entire circumference of the Earth. And everything up here is just moving at these blinding speeds. We're talking up to 18,000 miles per hour. Incredible. Okay, so we're leaving the satellites in our dust as we head for the moon, a cool 240,000 miles away. From here, I can see it so clearly, and it reminds me of a fun little fact you might not know. It's not perfectly round. Nope, it's slightly squashed, shaped a bit more like an egg. Wild, right? With the moon in our rearview mirror, we're now cruising past the gas giants. Jupiter, Saturn, they're absolutely magnificent from this angle. Earth, well, it's pretty much just another star in the sky now. The silence out here is just so profound. Whoa, what was that? Hold on. A flash of red just zipped past the viewport. Liam, did you see that? I swear, I think that was a Tesla. Yikes, a little too close for comfort there. We're so far out now that using miles just feels, well, meaningless. So out here, we switched to astronomical units, or AUs. As you can see, 1 AU is that huge distance from the Earth to the sun. Right now, we are 100 AUs out. That's over 9 billion miles from home. Just let that sink in. Whoa, okay, the whole ship is shaking. Liam, what's going on? Okay, he's telling me we're crossing the termination shock. This is basically an invisible boundary where the solar wind from our sun just violently smashes into the winds from other stars. It's a very turbulent welcome to the edge of our solar system. Next, we've got to navigate the Oort cloud. It's this huge, almost ghostly sphere of literally trillions of icy comets all around us. But once we're through that, we will officially be in interstellar space. And just like that, we've done it. We are officially in the space between the stars. So, now for our main destination. Now, while our galaxy does have a supermassive black hole right at its heart, that's a journey for another day. We're headed for something a little closer. But believe me, it is no less fascinating. Okay, so our target is a black hole called V616 Monocerotis. Let's just call it V16 Mon for short. It's what's known as a stellar black hole, which means it's smaller, but don't let that fool you. It still packs the mass of like 9 to 13 of our suns into a space that is unbelievably tiny. So what is a black hole really? Well, try to imagine a star, a truly massive one, way bigger than our sun. When a star like that runs out of fuel and dies, it doesn't just flicker out. It collapses in on itself with this catastrophic force. The gravity becomes so intense that it literally punches a hole in the fabric of space-time, creating a well so deep that nothing, not even light itself, can climb out. Okay, we're approaching now. And this is where things get really, really strange. Now, I'm not crazy enough to go any further myself. That's a job for Liam. I'm going to send him in to explore what lies beyond the point of no return. And this is it, the point of no return, the event horizon. It's not something you can see, but make no mistake, it is the most final boundary in the entire universe. Once you cross it, there is no coming back. Liam says he's ready. All right, buddy, let's see what happens. And there he goes, plunging right toward that horizon. From out here, where it's safe, it feels like reality itself is starting to break down. So as Liam gets closer, his time actually slows down compared to mine. That's time dilation in action. The very light coming from his ship is being stretched out by the gravity, which makes it look redder and redder to me. To my eyes, it looks like he's slowing to a complete stop, just frozen there at the edge. And now he's starting to stretch. Wow. He's literally being pulled apart, stretched thinner and thinner, just like a piece of spaghetti. I mean, you read about this stuff, but to actually see it, it's something else entirely. And what we're witnessing has a name, and it's as brutal as it sounds: spaghettification. Basically, the pull of gravity on the front of Liam's probe is so much stronger than the pull on the back that the difference is literally tearing him apart. He's being stretched into this superheated stream of atoms, glowing brighter and brighter until, poof, he's just gone. He's gone, vanished completely from my view. But the physics says that from his perspective, the moment he crossed that horizon, he'd be in a state of perfect freefall. He wouldn't feel any of that stretching or the heat. He would just fall. Into what? We don't know. The connection is lost. Liam is, well, he's somewhere beyond our understanding of space and time now. Whatever he's experiencing is a total unknown. All right, I'm turning the Invincible around, time to head home. But there's this one question that's just sticking with me. We've seen the edge of reality, but what's actually at the center? It makes me wonder, should we go all the way next time? What do you think?